Here's a case study of how the IRSA tool Finder chart can be used to investigate a list of sources in images as well as in catalogs, and specifically make catalog one-to-one matching work. I'm also following what turns out to be plotting example number 2, which includes a target list, which you can download and use yourself. This example also has a link to the journal article that came out of this work, which includes discussions of individual objects if you want to learn more about these sources. Let's go back to the Finder chart page, go to multiple positions, and go and find that list of targets that I have. 300 arc seconds is maybe a little bit big for what I want. I'm going to put in 200 arc seconds. Display size medium is fine. Many of my sources, it turns out, were detected in IRSA, so I definitely want to choose that. Everything else is okay. Yes, we're going to search the corresponding catalog. The default search radius is 5 arc seconds for the relatively high spatial resolution surveys, but larger for IRSA because the spatial resolution is just so much worse than these other surveys. I'm going to click the one-to-one match. What this is going to do is for each one of the target positions that I give it, it's going to find the closest match by position for each one of these catalogs and give me one and only one line for each of these catalogs for each one of the input sources. So for Sloan, 2Mess, Wise, and Spitzer, 5 arc seconds is probably just fine in general, but it turns out for this particular source list, some of the positions are really bad. So I'm going to put in the maximum source radius of 15 arc seconds just to make sure that I can find the appropriate match for these catalogs. For most of my sources, it should find a match within 1 or at most 1.5 or 2 arc seconds. But for some of the sources, the nearest positional match is actually quite far away. Okay, search. All right, so here's the list of sources that I uploaded. It added a column of row numbers just for counting purposes. Let's look first at the 2Mass catalog. This is what I mean by one-to-one matching. Here's the first source. It's an HD source, and it found a match in the catalog that was really close to the position I gave it. Go down to the 5th source, and it did not find a match within the radius that I gave it, but it still has a row. Same for the 6th source. So I mentioned that some of my positions are really bad. Let's change what's plotted. Let's make the plot take up more space in the browser. Instead of right ascension and declination, let's just plot the counter, the row counter, CNTR01, and then for the y-axis, let's do the distance. Apply, close. So yeah, it's not crazy. We're doing okay. I mean, most of the matches are well within 1 arc second, but there is a pretty long tail there going out to some pretty long distances. I mean, 12 arc seconds offset, we're really going to have to investigate some of those matches to see whether or not we believe that is really a match. So we can click and drag in this plot to select the sources that are the biggest offsets, and we can filter it down. So now we just have the 35 sources where there's the biggest offset between the position I gave it and the match that it found. So what's the story with this 12 arc second source? Oh, it's an IRSA source. Maybe 12 arc seconds isn't crazy. Let's go up here and find row 222 and see what it looks like. There's a lot of sources in that field of view. Let's make sure that it's zoomed in. Oh, I bet that source is the source of the IRSA flux. Let's measure what the offset is. Let's go over here and measure the offset. Try to center that a little better. It's like 40 arc seconds off from the really bright Wise source. So this is going to take some investigations. It's going to take some time to sort this one out. Since one of our scientific goals was to figure out which of these stars have an infrared excess, let's go back and make a different plot. Let's go over here, cancel these filters, and go over to the Wise catalog. Let's change what's plotted here. For the x-axis, let's do W1M Pro minus W4M Pro, and then for the y-axis, W1M Pro, and we want to reverse the y-axis to make sure that the bright objects are at the top. Apply, close. Okay, so probably these things are saturated at Wise 1. Maybe not Wise 4, but probably Wise 1. They're really bright, and they are doing some very strange things in this diagram. If I click on one of them, that one's row 289. So let's go here to 289. Yeah, I bet that's saturated. So here, these things are probably photospheres because they don't have any infrared color. They all have a WISE1 minus WISE4 near 0. So those probably are just stellar photospheres. What about this one? That one's 215. Let's look and see what that one looks like. Whoa, what is that? It's saturated though. It's not clear exactly what's going on, but it's really bright. It is definitely doing something interesting there. What about this one? This one's 269. 269. Another really bright source in the infrared. You can see it's rising rapidly. By the time it gets to IRSA brightness, it's really bright. But even for WISE1, it's really faint. And it's barely there, if that, at 2 mass. And probably not really there optical. So whatever this thing is, it's got a rapidly rising SED. So this is the idea. You can go through the entire catalog of sources one by one. You can interact with the images. You can overlay catalogs. You can go do additional catalog searches. Like for this particular source, you could go through and pull sources from the Allwise reject table to see if there's measurements that didn't make it into the final catalog but might still be of use. You can also compare results from the Allwise source catalog to the AllSky source catalog. Are you getting the same fluxes, or are you seeing something weird in the images and you want to check? When you're ready to download data, you go over here and cancel the filters and then prepare download. Then you can choose the file type. FITS files are going to be the original FITS files that correspond to the things that you're seeing. This is the file name, and you can choose to save it on your local disk or in the IRSA workspace. When you click Prepare Download, it's going to go spin off and start packaging it for you. To save the catalogs, you want to go and click on the diskette, and you can save it in any of a variety of formats. But because we did one-to-one matching, each one of these catalogs has 316 rows. So it becomes trivial to band merge these catalogs because each of them have the same number of sources. Even when it can't find a match, it still has a row for it. So this is the idea. You're interacting with the images and the catalogs. You can overlay catalogs on the images. You can explore what the images look like. You can see if you believe what the catalog is telling you. It definitely does pay to go back and look at the images to see if the target match that the computer has done blindly by position makes sense. It does make a ton of sense to go check and see if the sources are saturated or if the catalog is claiming a detection, but it should actually be an upper limit. It really makes a big difference to check and see if what you're doing makes scientific sense.